Hello, everybody, and thank you to the organizer for inviting us to the event. My name is Thibaut. I'm in charge of project and business development for TELAQUA, and especially in companies with the vine and wine industry. We are a young company which have been created in 2018, and we're based in Marseille. We have approximately 20 employees. Our mission is to help farmers optimizing their irrigation practices and their water consumption by providing a solution for irrigation management. So today I'm going to talk on vineyards, which is actually relevant because the idea of creating the company came from Chilean vineyards, where the father of one of our co-founders worked for more than 40 years in irrigation system designer. Thanks to his experience, you realize that often in irrigation processes, we mostly focus on how much to irrigate and when to irrigate. And for this, we use empirical knowledge and all kinds of sensors, such as weather stations, soil sensors, and plant sensors. But what happened upstream on the whole network is rarely taken into account. So this you can see on the slide that there's like a closed box where which goes from the pump to the dripper, passing through the pipes, the valves and the filters, which is absolutely not controlled. And you may know that on top of the key indicator for irrigation, in addition to agronomical sensors, there is the pressure. Pressure should be the first thing you look at when talking about irrigation processes, because whatever the amount of water and the moment you want to irrigate, if the pressure on the system is not good, your decision won't be executed as you want it to be. So what may happen by looking at the pressure? Here on the graph, you can see on the right graph, you can see the pressure variation in a valve during a 4-hour irrigation. So normally the pressure has to be stable so that the pressure, the flow and the duration of irrigation allows to deliver the right amount of water. But in this case, you see that the pressure goes up and down for the whole time of the irrigation. So depending on the dripper's flow rate, they could lead to 20 to 50% of water that is actually non-delivered to the plant. And the cause of the problem could be valve regulation, broken pipes, clogged pipes, for example. So it's very important to measure the pressure at the valve point. On the other end, controlling the pressure allows you to know exactly when irrigation starts and ends, so there's no risk of over-irrigating. In these two examples of measuring the pressure, under irrigating and over irrigating, they may have a big agronomical impacts, and especially at different vine phenological stages. So we are reaching the point of our solutions. We have developed global management tool for irrigation system, thanks to connected object and sensors positioned to the whole network, as you can see on the slide. And the management platform, we see the mobile and web app, the farmer can monitor his system remotely and in real time. You can see here on the slide 2 different sensors that we've developed, named the Mano and the Agromot, that measure indicators such as pressure, like I said, and flow at key point of the network, so pump, valve, filters, to monitor the proper functioning of the system and be alerted in case of anomaly, and ensure predictive maintenance for irrigation equipment. We also connect the pumps and the valve to control them remotely, monitor all the operation of irrigation, and also monitor electricity consumption. So finally, we also integrate agronomical and weather sensors to predict and assess the impact of irrigation. So as you see, the idea is to combine hydraulic and agronomy, and our solution allows to plan, to monitor, and to analyze the irrigation operations, all the irrigation operations from agronomical point of view and economical point of view. Here you can see some screenshot of our platform that is ergonomic and easy to use. It allows both the operators and the technical directors, or even upstream department like CSR, to achieve the operational excellence and optimize their water resource to achieve the project and production goals. And that all the data can be exported and analyzed on different time steps. So to finish, and I hope it's clear for everyone, here in the 21st century, the water consumption has been multiplied by 7, and as you may know, 70% is used by agriculture. So water availability will be one of the key challenges to meet. So our solution leads to operational efficiency in terms of irrigation by monitoring and increasing responsiveness in case of anomaly. So it leads to better productivity, ensuring the homogeneity of irrigation, which is the most important part about irrigation. Thank you for your time. This is my personal contact, so I'll be interested in talking with one of you if you want, so don't hesitate.